Okay, we're gonna do a lab on the bending of light, or Snell's law. So we're gonna start out by opening the simulation and click play. I'm gonna use the introductory one here. We have a couple tools. We're only going to use this protractor, and so we have a laser. Now the laser, they indicate with this dashed line where the laser is going to hit. And so we're going to put the protractor right there. And we can use the protractor then to measure the angles of incidence and refraction. Now, one thing I kind of like about this lab is we have to manually put the protractor there. And so we might actually get a couple errors. So things will not work out perfectly like they do in some other simulations, which is nice. But yeah, so to start out, we have, obviously two different materials, and the default is air and water with indexes of refraction of 1 and 1.33. And we can change these. If you look at the options, there's air, water, glass, mystery A, mystery B, and custom. And to start out, we're going to use just air and water. And the reason is we know what the index of refraction of water is. And so that's kind of the goal of this lab, is to find the index of refraction of this material. So we're going to test things with known material. And then for part B, we're going to select one of these two mystery materials. So in that, you can see, they don't tell you the index of refraction, so you have to figure that out. But we'll do water first, so we know that we're doing things right. And yeah, what we're gonna do is we're gonna make a table, and like right now, I set the index of refraction to be 5 degrees. We can move this around, or the angle of incidence, sorry, 5 degrees. They show the refracted ray and the reflected ray as well. We're not going to use this, but just to show what it is, we can see that it looks like this reflected ray is pretty dim. And this can measure, like here, looks like 2% of the light is reflected. And so this one should be 98 or 97.3%. 97. Oh yeah, 2.07. So yeah, these two numbers add up to 100%. So we can see, how much of the light is transmitted into the water and how much is reflected. And as you change the angle, you can see just from the color that more light gets reflected when we have a greater angle of incidence. Like here, it's 28.3 roughly, and then 71.7. But we're just going to focus on Snell's law, so we're not going to actually use this thing. So let's put it back. Okay, so we're going to make a table, and we've got, like, I started at 5 degrees, and it looks like the angle of reflection is about 5 degrees as well. So you put that down in your table, and then we're going to go to 15 degrees, and that's maybe 12 degrees for the angle of refraction. I think I said reflection last time, but the angle of incidence and the angle of reflection should be equal to each other. And we'll just go in 10-degree increments. So here's 25, and it looks like around 20 degrees for refraction. And go all the way up to 85 degrees and measure the angle of refraction. So you'll have a table with the angle of incidence, angle of refraction, and a fair number of data points. So let's look at Snell's law. We're going from air to water. So the index of refraction of air is just 1. So we're going to have 1 times sine of theta is equal to n, which is the angle of or the index of refraction of the water in this case, and then sine theta r. So the data table, you have angle of incidence and angle of refraction. You'll have a table that'll look something like this. From like 5, 15, and so on, up to 85 degrees. And you'll upload the table. So I want to see like your actual data. So let's see. Yeah, here's the, make a table of your data and upload it here. And of course, name and description like table 1, and then describe what it is. Okay, now here's Snell's law. And so our data is our two angles. These are our variables. And we can see that these are the relation between the data that we've collected is definitely not linear. So what we want to do then is linearize it. We'll do x equals, actually I can do that over here. So again, you have to figure out how to linearize your data. So you will do that. And again, at the end, what you do is y equals, or you basically you take Snell's law and just make your substitution. So whatever you said x is, then you would plug that into Snell's law, and then ultimately what you would do is solve, and as usual, you should get a constant times x plus another constant, which may be 0. And again, if it's just in that form, then you have correctly linearized your data. Now, there's actually two ways you can do it. In this lab, you're choosing the angle of incidence. So x should be related to theta I. That'll work just as well if you do it the other way. But the independent variable should be related to the angle of incidence because that's what you're controlling. And the angle you pick determines theta r. So that would be the dependent variable. So y should be dependent on theta r. And then what you'll do is you'll make a new table, which again, you do not need to upload this table. So you're going to have a new table with x and y where you're going to enter your data in a spreadsheet. And then you can, just use the spreadsheet to calculate the values of x and y by referring to these theta I and theta r. And that's the data that you're going to plot. You're going to plot this xy as a scatter plot, just like we've done many times before. So yeah, here, again, what you'll do here is you'll just say like x equals whatever you wanted x equal to, and y equals there. And then you're going to plot your linearized data. Do a best fit line and r squared value. Again, I hate the way they look on the graph because they have, like 16 significant figures or something, which is ridiculous. So what I would do is just write those values down. I always delete the equation itself just because I think it looks stupid. But at least write down the information, or just the slope in this case. You don't need the intercept. So here's, this one. You uploaded the table, and then you choose what your x and y are and write that down. Oh, and I say check to make sure that it works. I don't mean you have to show that. I'm just saying do that. You're on your own. You don't have to show it though. Okay, and then you plot your linearized data. So again, you have like figure 1, axes, and the graph itself. So, okay, and now it's asking for the slope of your best fit line. So you just write that down. And r squared value, just write that down. Should be close to 1. And then use your best fit line to find the index of refraction of water. So yeah, that's it for part A. And again, you should get around 1.33. If you're significantly off, then yeah, then kind of look over and something went wrong probably. I did this, and I was happy to see that there was at least some error in this. I got 1.31, so it was a little bit off, which is good. Okay, and then we're going to move on to part B, which is going to be the exact same procedure, except we don't know the index of refraction in this case. So, oh yeah, I should probably add something here. So, like, here's where you determine the index of refraction of water. You might as well compare it to the known value for part A. So I'll modify that a little bit. But then part B, we're going to uh, do the exact same process. But you're not going to have to like unload or upload quite as much here because you've already done it. It's the exact same procedure. Now we're just using a new material. So you'll indicate which of these mystery materials you're going to use. So like what you write down here is going to be like A, for example, if that's the material you're using. Otherwise, write down B. So basically, that's all you're going to do there. And so make a table of your angle. So not the linearized data, but just the data itself, just like you did before. And then linearize your data. And you don't have to tell me like what changes of variables because they will be exactly the same. So just do exactly what you did for part A. And you will need the best fit line, but R squared was just a check. We're not going to do that again. So your slope should be different in this case because you have a different index of refraction. But yeah, so basically you go directly from the table to uploading the plot. And then here's the slope. And then the index of refraction of your mystery material. And then that is it. So, yeah, it should be a pretty straightforward lab because if you do part A and get 1.3 something, then you probably did things right. And then you can just do um, the exact same thing for B, same substitutions. What I did I always run through these to test them first before talking about them. And I literally just kept the exact same spreadsheet, just deleted the data from part A and then put new data in for part B. And yeah, so first run is a test. If you get that right, you should get part B right as well. All right, so that'll be it for this lab.